So you can log in and you can register. So you make an account. You add your first name, last name, your ITCN for now. This could also be your social security number or something else, and your email address, and your password, of course. You then fill in your role. So let's say you're a teacher or you're a validator, and we would register. We get signed in. From here, we get the overview of all our organizations and badges. We don't have any organizations or badges right now, so you'll start off by making organization. So we select, um, let's say we're a company called LinkedIn.
For example, no copyright claims.
Als je het inzoomen? Of?
Nee. Okay. Ja, ik weet niet, het is jullie demo, maar...
Ja, dus hem in te leveren.
So we enter the fields, so the name of the company, their website, their email, and a brief description of what the company is. We submit it, we get a message that it's created successfully. If we now go back into our home, you can see the issuer is added. Let's say we want to add another teacher or validator to our organization. So I'll first check the ID of our issuer. And we enter the user we want to go to and issuer we want them to be assigned to. For now, we use IDs because it was the fastest way for us to show it to you due to some time boxing issues. So we attach the user. We should get a message. So if I'm right, we should have the issuer connected to the organization now too. So we want to create a badge after that. So let's say we get the...
So these badges the images are not hosted on the blockchain directly, are they right now?
No,
because
right now they are.
They are hosted on the blockchain right now, so they're imported to base 64, so they're basically a bit encoded, and they are put directly on the blockchain. So it is all of this is actually fully decentralized right now.
So we have the basic details again, so the name of the badge, the description, the criteria to get the badge, and the issuer organization want to have the badge for. We then create the badge, we get a message that it's added. When we now go to validate the badge, you will get the message in here that there's badges to be validated. You can collapse it and get more information. You will see the status, is it validated or is it not. So let's say we want to validate it, we get a message that it's validated. And you should be able to find it in here. And you can show to be logged in as another user, and you'll also be able to see the issuer organization and the same badges. So
you're a user?
What's your role?
His role is to validate.
Validate.
Okay.
So I'm here as the LinkedIn, and if I go to validate, I know I'm not already validated, but I can see here on my badges. Coffee badge. Scroll here. See that it's validated.
So let's say you want to issue this badge. So for now we use the same user as we just logged into on Casper's computer.
Yeah.
Just for convenience purposes, so it's faster. Uh, and we add their default information, so their ID, their name and their email address. From now it doesn't check, but in the end it should check to be correct. So you always get the correct result, or the correct student you want to give it to. Then we add in the evidence, so why should he deserve the badge? And we award it to the student. We'll now see that it's validated here. He can show that he can also validate it.
And also this point, if I was a student, I would this functionality what maybe is not the best one, but also I can see that I'm getting this badge. I should be getting, but it's not validated yet. So I can see like, okay, I should have this. And maybe in this point, teacher can, okay, but I did this evidence, maybe got discussion.
So I validate it now.
And obviously it's updates here.
Yeah.
And I think that's the system for how we have it now.
I think that's most part of it.
Student view. I missed it somewhere.
Yeah. So
The one getting the badge.
Yeah.
So that's basically this view what we were showing here. At this point, I'm simultaneously logging just a general user, so I can validate and get badges as the same account.
So the permission and rules
Yeah.
settings are not quite there yet, but
Yeah. So during this project, we didn't make this membership service provider.
Well, we did it on the blockchain. It's just not imported into the front end.
okay.
So there's no. Normally, if you would log in as a teacher, you wouldn't see
No,
validated.
yeah.
Yeah.
So
It's-
yeah, so the functionality is on the back end, but not in front end yet.
Yes.
Yes.
I can show you the backend, but there's really not that much to show. It's basically a lot of lines of code.
Yeah, I saw it in the video.
Yeah.
If you really want, I can take you through it. But
No, it works.
Okay.
I'm interested in the blockchain.
Yeah. And yeah, I'm really interested in the transactions.
Yeah.
And
Did you put in smart contracts?
So well, then maybe jump to the code.
Yeah.
Show the actual chain code. Can you give the screen to Uday?
Yeah, sure.
then I would actually need to go there.
Maybe show the playground the easiest way.
It's probably the easiest way, but I don't like playgrounds, and so it crashes on me. So I'll just do it right here. So the smart contracts are pretty simple. It's basically JavaScript, and these smart contracts are. First, I have to show you the model file. It will be a bit more clear. So you have some model file, which are the assets, so the badge, which are just created, the issued badge.
Yeah, so this
You
one
have
in
the
the
users,
video.
exactly. And you have your transaction, what kind of parameters you want, the entity ID, the name, the URL. And after that, we can say create badge. This is a really simple one. It uses a factory, and a factory basically creates a blueprint for something you can fill in. So you can say, okay, I want a badge class, and it needs to have this ID, and you can fill in the rest from transaction data, and you can return it. There are some weird things going on, because the entity ID needs to be from the front end server. You cannot implement that in the back end. That's because there's no auto increment, because you can have multiple nodes, and the code won't always execute at the exact same time. it could change and one could come in between, and that would mess it all up because they would both get rejected,
Yeah.
and then no one would be created. So you actually need a front-end server to handle those kind of requests, because the code needs to be executed multiple times, and the result always needs to be the same. It's actually an interesting problem which they may fix in future updates.
It has been fixed in the past already, and I don't know if you can remember. Martin can maybe remember it. Notes from what's it called? It was a document management system where people could edit in documents all over the world. And they would be merged at certain points, and they simply raised exceptions when this happened and appointed the server to solve the exception.
Yes.
So if someone gets in between and they get the same number, it goes to the exception handler and they say you get this number and you get that number. Fixed.
The problem is that the nodes in that case wouldn't reach consensus, and the default response for that is to reject it. And that is the problem. They could fix it the way you said, but they have not.
It's not implemented.
And that's the the quirk, no, but it is the Achilles heel, the
Yeah.
bottleneck with decentralized
Everything.
asynchronic.
You also have no random function. It always needs to be executed exactly the same, otherwise it's just wrong.
Yeah.
And the other ones, they almost look kind of the same, except for validate new batch. You get it from a registry because it's already created. You just want to change some values from the batch.
Yeah.
And I think issue batch is almost the same as creating a new batch. The same goes for validate issued batch. You have your rejections field, so you can also see if that's rejected. We could implement it a bit
How
further.
many nodes
too.
are running?
Currently, there are 2 running, but they're both running on 1 VM. So it's you could spread it out, but it's not really efficient this way. It is now.
Yeah. Just for proof of
For
concept.
development purposes, you use one node basically.
Yeah.
So that's what Ivan also said.
Okay, so your proof is simply that you can issue batches on the blockchain.
Yes. But as
Okay, that's
far as now, I must say the language they use here, so it's basically chain code, it is not that far. It is really basic. I think one of the most complex things I implemented was this abstract class, and even then it can only extend it and not implement it, which can be an issue because let's say these are all participants and you would want to create something that can get all participants.
So the advice is simply
Not yet. Don't use
not
it
yet.
yet.
In this
In this case,
case,
yes.
yeah.
It needs to be more evolved. It needs to have at least implementation instead of just extending. And
Interfaces
started
are missing.
Ethereum in the beginning because of the pricing problem. Because if Ethereum fixed this problem, I can't imagine they haven't fixed it.
Ethereum.
That's
let me
much
think.
more mature.
Which problem? Specify.
That the language isn't on to par yet.
Yeah, no, well, that's also, of course, that's how developers see the language. Like chain code is not mature, Solidity is not mature, but you can do it also Ethereum, Python nowadays, so I don't see that's a problem. But maybe like this whole validating part, like there's no point to put it on a blockchain. Another thing is to store
For the
eventual-
validation you can do it externally. It's just,
Yeah.
just the storage which is important to have on the blockchain.
But yeah, the eventual, the final storage of issued batches,
Yeah.
that's something could be explored, but not probably with this fabric.
Yeah, for now, not. Like maybe in like 3 or 5 years that it's more.
Fabric is not
more
ready.
improved.
That's the point.
Yes.
Yeah.
This moment, yeah.
And
Okay,
just-
what's interesting is look back on why you chose the Fabric, and now you find it isn't ready.
Yeah.
That's an interesting loop to make.
Yeah.
Did we observe everything in our initial choice?
I think
Should
because
have
like
observed.
during the beginning of the research we focused really much of that validating process and how we should cover it. But now looking back and thinking like we could hand it in more traditional way and concentrate more of where we're gonna store the batches.
Yeah.
And that would change how we do the research completely. Because then we focus so much on executing the chain code, not thinking about blockchain as final storage.
Because does it is it a single thread or
Not amused.
do you
Heel enthousiast.
every change or every addition you do in the system on the front end, is it logged as a single transaction in the blockchain, or do you do multiple attempts or items at the same time?
It's single transaction.
Okay.
Okay. And it's not a problem with Fabric because it's free. You host it yourself.
No, but not free, but it's more about scalability. So I don't think that in this case you will have like 10,000 transactions per second, but I think that could be a bottleneck if you scale it up to
For
one
Fabric,
store.
it's not an issue as far as I
No?
know.
No.
It's really fast.
It was
The
like
basic issue is
2000, 1000, 2000
Yeah,
per
it's
second.
really fast.
The basic issue is the badge, valid badge.
Yeah, and like the process of verifying badges.
Yeah.
Like from a customer point of view, like I want to verify it. It should be some verified badge verifying service where I do it. And like if you host it like in a Fabric, it's a permissioned blockchain. You need to have permis access to each customer. Way too complicated. So at that point, it should be on a public blockchain, so everybody can have access as anonymous. But with blockchain, the whole validating process is undoable. So this conclusion like goes in two ways right now.
Okay, you're gonna write down these conclusions?
Yeah.
Yeah, that one is good. I'm interested if we look at other blockchain implementations, what it will solve.
Maybe like as an advice, just to see it as a final storage, not use it as a processing.
Yeah.
I think it's kind of more basic. Right now you have a lot of participants, a lot of different roles within the blockchain. And if instead of badges you would have something like art or movies, actually movie rights, you could really easily sell them, but you wouldn't actually have different roles and different validators because it's supposed to be trustless, which is pretty hard with validators in between and a lot of different people that need to touch it before a transaction can be.
Bottom line question: does the blockchain have a solution for the problem we posed?
Can you specify the problem? Because there's multiple problems.
The basic problem is if you issue badges, can they be stored in such a way that that the validation isn't an issue? So you got a badge, it's in the blockchain, and when I see
And
your
everybody-
badges,
yeah.
I know they're issued by the guys who are on Mentor.
Yes, that is
Extension
that's fixed.
yeah.
You can see which organization, which teacher. Yeah,
Because that's something that
that's
you
it's
can't
traceable. So
see or fully trust in the current way
No,
of
that's the
handing
big
out
issue.
badges. Because if I do like FH1CT
yeah,
as an issuer, I can make my own spoof badges
Yeah.
and hand them out to all of you, and you can say to your teachers, look,
You've got badges.
Yeah.
badges C is from FICT, not being aware that it's in one instead of an I.
For that purpose, it could work on a blockchain because it will be there.
yeah, it solves that problem.
Yeah, it solves
Yeah.
the problem.
Yeah.
But is it advisable? The money comes in.
Yeah, that's
Yeah, but money is no-
money is not the issue.
Yeah.
I told you before when you discarded Ethereum that if
Yeah.
you diploma line costs money, it's printed on
You know
certified paper.
what Fontes is paying a year to keep all diplomas for 50 years in one or two warehouses stacked full with diploma paper.
And it has to be maintained, etc. And if it's in a blockchain and costs some kind of money per student,
It's easier to maintain though.
absolutely.
And scalability
Depending,
is
depending on which blockchain you choose.
Yeah,
Yeah,
but
and
still,
that-
but
That's
So-
more.
No, but still, because you
fancy.
don't handle with paper, it's
Yeah,
data
of
on
course, yeah.
It's data.
yeah.
on stored hard drives.
And if the process on validating and issuing a badge streamlines the day-to-day process and also make it more efficient, that's also saving time, meaning
And
saving
money.
costs.
Yeah. And the other issue is it's on the blockchain, so if we burn 2 nodes, no problem.
Yeah.
That is true.
If we burn this warehouse,
Now
big
this,
problem.
no. In this case, it doesn't work because we only have 2 nodes.
Yeah, they've only one
Yes.
machine.
Yes.
In this case,
Yeah, okay.
development purposes.
I'm very interested in your final advice. In this one. See if we further follow it up.
Only one minor note, not for the whole project, but more in what you showed on your user interface. Why do I have to give out an ID, which is unique, but also the
Name,
email address?
Yeah, and an email address.
Yeah. So it's doubling of.
Why don't
same-
you ask your date of birth and if you're a male or female, and I don't know.
No,
What?
like we said, we don't handle the user premises.
No, I don't know, but
Initially was to just log in with your email address and your password.
Yeah.
No, but you have to, when you
Som
you have to-
afmaaier
okay,
is genoeg.
you have to-